Hello everyone, welcome to Chem at that point. Dear student, today I will discuss chapter 7 alcohol phenol ether. It is a class 12. So it's a very competitive based questions. So let's start. The first question is propan has a higher boiling point than that of butane because, dear student, who is in the right answer? Propan has higher boiling point than that of butane because first option is butane undergoes intermolecular ionic bonding. Okay, dear student, butane, right? That means CH3, CH2, CH2, CH3. It is a butane. Okay, intermolecular ionic bonding. No, it's not a ionic bonds. Okay, so first option is wrong. Now move to the second option. Propanol undergoes intermolecular H bonding. Intermolecular H bonding. Dear student, what do you mean by intermolecular H bonding? This is the first question mark, right? Inter means two molecules. Inter means two molecules. Got it? Inter means two molecules. So alcohol, they have intermolecular interaction, H bonding. That's why they have the higher boiling points. Okay, the second option is correct. Okay, third option is the propanol undergoes intramolecular hydrogen bonding. Dear student, intra means same molecule. Yeah, one molecule. One molecules. So alcohol, they have does not contain intramolecular H bonding. The third option is wrong. Butane undergoes no. Butane, they have no alcohol group that attached to the oxygen, nitrogen and fluorine. Then it can show the H bonding. But the butane, they have hydrogen are attached to carbon. They have does not showing the H bonding. The second option is correct. Any confusion? Okay. If any doubt, then you write down in a comment box. I will explain how second option is correct. Okay. Now move to the second question. The boiling point is clearly visible. Yes. The boiling point of ethanol is higher than that of dimethyl ether due to the presence of ethanol is higher than that of dimethyl ether due to presence of H bonding. Okay, so right answer is H bonding in ethanol, right? Option A. Got it? Then third questions. The reducing agent among the following is reducing agent, right? What do you mean by reducing agent? What do you mean by reducing agent? What do you mean by reducing agent? Itself oxidize another substance, it will reduce, right? Got it, my friend? It is a reducing agent. Okay. So first is CrO3H plus. It is a oxidizing agent. Keep in the mind. KMnO4. It is a strong oxidizing agent. Strong oxidizing agent. CrO3 the mild oxidizing agent. Lithium aluminum hydride is a strong reducing agent. O3 ozone. Ozone is the oxidizing agent. Do you understand my point? The right answer is 3. lithium aluminum hydrate. Then question number 4. The below mentioned reaction can be classified as, the first is the alcohol react with NaH. Got my point? So it will be form sodium pentoxide. Okay, then it reacts with sodium cyclopentoxide. This is cyclo are there. Okay, 1 2 3 4 5 and cyclic are there. Sodium cyclopentoxide. Then reacts with the methyl iodide. Okay, methyl iodide. Dear student, all of you know methyl, right? Methyl means you know the Me, right? That means H single bond I. Got my point? Iodine is a living group. Iodine is a living group. It will be easily leave, right? O minus Na plus. O minus, this is a nucleophile. Our Na plus is the electrophile. Na plus is the electrophile. So that nucleophile attack this carbon, and this is living. It is a living group. It will easily leave. Got my point? Then it will be form this compound. Got my point? And that functional group is comes to the ether. Ether GF, general formula is ROR. Okay, R is the alkali group or aryl group, whatever. So it is a Williamson synthesis reactions. So 4 options correct. Williamson ether synthesis reactions, because in this process ether it will form. Do you understand my point? Any confusion, any doubt? And that mechanism is goes for the SN2 reactions. SN2 reactions. Keep in the mind, dear students. Okay. Then move to the question number 5. Alcohol are comparatively more soluble in water than hydrocarbon of comparable molecular masses, because simple answer, right? Simply you can say alcohol are comparatively more soluble than in water, because alcohol and water they have the H bonding. This very simple things are there. Alcohol and water, in these two molecule they have hydrogen bonding. That's why it can be easily soluble. Do you understand my point? I think my point is very clear, right? Alcohol and water they have showing the H bonding. That's why it can be easily soluble as compared to hydrocarbons, right? So which one the correct option? You can read the carefully 4 options. Alcohol from van der Waals bonds with the water, no, never. Not van der Waals force, it's a H bonding. Okay. Then alcohol from covalent bond with water, no, only H bonding. Do you understand my point? Covalent bond means sharing of electrons. Do you understand my point? Covalent bond means sharing of electrons. Alcohol and water, they are not sharing of electrons. They are interact with each other. And that interaction is called the H bonding. And H bonding is a 2 types. One is the inter and another is the intra. And this comes into the intermolecular force of attraction. Inter means 2 molecules. Got my point? 2 molecules. And intermolecular force of attraction comes into the 2 types. One is homo, another is hetero. Homo, hetero. Homo means same molecular there, just like HF, and that in between the HF they have the H bonding. This is the homo. Hetero means 2 different molecules, like water, alcohol. This is the 2 different molecules. In between these 2 different molecules, they have the H bonding. It is known as hydrogen bonds. Got in my point? So option 4 is the correct answer. alcohol from H bonding with water while hydrocarbon do not. Any confusion? If any doubt, don't worry. In comment box, you write down whatever your doubts. I will explain. Got my point? Now come to the question number 6. Question number 6. The formula of allyl alcohol is very simple, right? So alcohol directly attached to carbon, they have the most to be sp3, and adjacent carbon they have most to be sp2. Got it my point? So option 2 is the correct answer. Got it? Any confusion? No. Thank you. Now move to the next question. Propan 1-OL may be prepared by a reaction of propene with 4 options are there. Okay. One is the acetic acid, S3PO3, S3PO3 no, S2, S6, B2S6 and NaOH and S2O2. Okay. This is the hydroboration or oxidation, right? In this process, it comes in the anti-Markovnikov rule. Am I right? Anti-Markovnikov rule. Okay. Propan 1-OL. That means CH3, CH2, CH2OH from propene. Propene means they have 1, 2, 3 propene, right? If you put B2S6 in presence NaOH and H2O2 hydrogen peroxide, right, directly alcohol are attached in the first carbon and it undergoes the anti-Markovnikov rule. Anti-Markovnikov rule. Do you understand my point? Any confusion? Any doubt? Okay. Now move to the next question. Question number 8. The IPSC name of the following IPSC name of the below compound is. Okay. It's very simple. Okay. So 1, 2, 3. Okay. So 1-phenyl propan 2-OL. Option A. Right. Then move to the next question. The alcohol expected to have the lowest pK value among the following is. Dear student, this question comes directly in CBSE. Okay, please have a look. Lowest pKa. Lowest pKa value. What do you mean by pKa? Okay, don't worry about that. I am here. I will explain with you what's the right answer and how to think. Is very important, right? How to think. Dear student, Ka and pKa, they have inversely proportional. They have inversely proportional. Okay. If Ka increases, pKa decreases. Do you understand my point? It just look which option they have high acidic. They have high acidic, the lowest pKa. Very simple things are there. They are inversely proportional. Do you understand my point? Okay. Then you can check. So 2,2,2 trifluoroethanol. Okay. You can draw the structure. You clearly understood why option 3 is the correct answer. Got my point? Option 3 is the more acidic. That's why pK value is very less. Then now the question 10. Ascent regions question. Be careful. It's very conceptual questions. So ascent is the para-nitrophenol is more acidic than phenol. Yes, because para-nitrophenol is more acidic than phenol. Is it correct? Yes, it's a correct. It's a true statement. Because nitro group the electron withdrawing group, they have attached in para position. Bolo. Any confusion? Now come to the reasons. Nitro group helps in the stabilization of the phenoxide ion by dispersal of negative charge due to the resonance. Yes, it's also correct, and this is the correct explanation also. Got my point? The right answer is the A. Both A and R are true, and R is the correct explanation of A. Got my point? My point is very clear. Am I right? Okay. Now, question number 11. The structure of A in the below mention the reactions. Okay, cool. So, PCC, right? PCC, and in presence of dichloromethane, right? That means CH2Cl2 are written here, right? CH2Cl2. PCC is the mild oxidizing agent. Pyridium chlorochromate, that full form is the pyridium chlorochromate. It's a mild oxidizing agent. The secondary alcohol, if you put PCC, you get ketones. Do you understand my point? Primary alcohol, you put PCC, you get the aldehyde. Secondary alcohol, you put the PCC, you get the ketone. Tertiary alcohol, you put the PCC, no functional group you can get. Do you understand my point? Yeah, keep in the mind these few points. Okay, keep in the mind is very useful to solve those questions. Okay, so clearly you can look option 2 is the correct answer. Second option, am I right? This is the ketones. Got it? Now next question. Dear student, it's a very interesting question, right? And solve this question. The product A in the below mentioned reaction is. So I just solve this question because you can understand why option A is the correct answer. Okay, I just solve this question. Have a look. Dear student, first option is the correct. Why? I will explain with you. Listen to me. CH3 and CH3, single bond CH, double bond CH2. Okay, you are adding some water, H2 in acidic medium. Do you understand my point? Very nice. First of all, I draw the mechanism. Is very careful, you can look. Pi electron density first. Dear student, what I am saying, be careful. Okay, pi electron density directly comes electrophile, because always negative charge goes to attack the electrophile. Electrophile not comes to the nucleophiles. The electrodensity directly comes to attack the electrophiles. Do you understand my point? So H2O in acidic medium are there. That means hydronium ion. Got my point? So that pi electron density comes to attack S plus ion. And you get CH3 attached to CH, single bond CH2, this come to the positive charge. Why positive charge comes in the left side? Why not right side? Because in left side they have more stabilized as compared to right side, according to Markovnikov rule. Do you understand my point? According to Markovnikov rule. Any doubt? Any confusion? Markovnikov rule. Got my point? Now, positive charge, they have less stabilized. If you rearrange takes place, then positive charge they come to the more stabilized, right? That means that is called the 1,2 methyl shift. 1,2 methyl shift. Got my point? Then CH3, C positive, CH3, CH, CH3, CH3. Got it? And that positive is most stabilized by 3, 3, 1, 6, 7, 7 alpha hydrogen. In this case, they have only 2 alpha, I think 3, this is 3 alpha hydrogen. Dear student, please tell me, 3 alpha hydrogen more stabilized? Yes, 7 alpha hydrogen more stabilized. Definitely 7 alpha hydrogen. That's why it can be rearrangement. This is the rearrangement case. Okay. Carbocation, they have the rearrangement. Less stabilized to move to the more stabilized. Okay. So please tell me, OH minus directly comes to positive charge? Yes or no? Right. So option A is the correct answer. Do you understand my point? Option A is the correct answer. How is the mechanism? Just have a look. If you don't understand, okay, pause the video, take a pen and paper, solve these questions. You clearly understood. Got it? Okay. So this is the last question, dear students. So I hope all are very well. So have a great day. Thank you so much for watching this video. Thank you so much.